Welcome back to R for Economics. In this video, we'll be talking about factor analysis. This is very related to the principal components analysis and eigenvalues and eigenvectors that we saw in previous videos. So this is part of the stats library, and here we want to look at the correlation plots. Bring in our data, empty cars, and our subset where we remove the some binary variables. Now, we can take a correlation plot of the correlation between all the data that we have in our subset. And we can use an ellipse method, which makes a graph like this, where we can see each of our items that we brought in data new and see how they correlate. Now, one thing that you can do with this type of plot that is hard to get generalizations from a plot like this, because everything is erratic, and you can reorganize them by just simply moving things around. And now you can see that things in this upper left quadrant are things that are positively correlated with each other and negatively correlated with the other things in the data. And then there's some positive correlation going on in this back end as well. So this allows you to actually see which ones actually have strong negative correlations and are likely to be moving against each other, and ones with strong positive correlation and likely moving together. Now, the factor analysis will take this information and break it down into parts. So we're going to factor analysis using the factanal command, data new, and we're going to retain 3 factors. So when we look at our output, we can see that it's done factor analysis, and it's given us our factor loadings 1, 2, and 3, and it's also given us our sum of squares and our proportion of the variance. And we can see that after 3 factors, we're pretty much at 87.5%, which is quite large. And this is saying that generic tests of this is positive. Now, the other thing in this output is the uniqueness. And large values of these say that its variance hasn't really been explained by these factors. Small values, as we here cite the number of cylinders, is very small, which means that these factors are capturing that effect from cylinders quite a bit, and even more so in the case of the weight. However, things like the DRAD are barely affected. They've only accounted for about 60% of the 60 to 70% of the variation in DRAD is explained by these factors. So this can be used. Now, another option is to actually use rotation. So these factors, there's no rotation there drawn directly, but one thing you can do is use things like Varimax or Promax. Varimax looks at the first and last variation and says, let's expand that to such that the first and the last are the highest they can possibly be. Promax says, you've chosen 3 factors, let's increase the variation of those first 3 factors as much as possible compared to the others. And it maximizes the variation of the first 3 factors. So we can generate those as well. And if we wanted to look at those, we can see that although it's changed the uniqueness a little bit, it's not by very much, but you can see that factor 1 is now taking a little bit more of the variation in factor correlation. Now, another thing we can do is we can actually plot these factors against each other. So factor 1, factor 2, and 3. We now know identified which factors we have. And we can see that if we look at factor 1 and factor 2, we see that these things are actually fairly close to each other with the exception of QSEC. And we also get this effect where we have this grouping off to the top right and a grouping down here in the bottom left of the factors. And this was seen in our in the previous videos, the eigenvalues and principal components through the GG biplots. So this is consistent with that analysis. Another thing we can look at is we can look at the rotation, or compare what happens when we rotate these. So we'll just look at the factor 1 and factor 2. If we bring these in again, we can see that these are the first factors that we had. And now we can add the points from the Promax to this in red. And we can see that we're getting quite a different movement in these two, such that gear and the rotation, in order to maximize those first three factors, it actually rotated this entire set almost 180. And by rotating it 180, it seems to have captured a lot more of the variation that we had before. And that rotation is maybe of benefit depending on what your analysis. Now, again, you can use this to generate the factors if you want to use them in a regression. And now you have three factors with loadings that you can use in order to generate the factors. And those loadings, if we look at them, these are the factor loadings here. And you can use those to multiply those to your series in order to generate factors that you can use in your analysis. Okay, that's it for factor analysis, and we'll see you in the next video.